Okay, when we were dealing with prime factoring yesterday, I had you guys use a factor tree. Factor tree was pretty simple. You had a number that we needed to prime factor. We thought of two factors. You know, if they were composite or if they were prime, didn't really matter. We just needed to think of two factors that would equal that number. We came up with 6 and 8. Okay, 6 times 8 equals 48. Then in this case, we saw that both of these were still composites. So there was still more factoring that we needed to do, right? Okay, so we have 6, and we're going to factor that one out a little bit more. What times what was 6? Well, 2 times 3 was. And then I told you that when we're doing this, we want to circle our prime numbers. So 6 was done. That was 2 times 3, and that was as far as we're going to get. With the 8, we prime factored that as 2 times 4. Circled the 2 because it's prime, and factored 4 out further at 2 times 2. And circled those because those were now prime. So 48 in its prime factored form was 48 times 2 times 2 times 2 times 2. That we have right here times 3. So that because there were 4 2's, that was 2 to the fourth power times 3. Okay? Remember how we did that yesterday? Today I'm going to teach you guys something a little different. And quite honestly, I like this way more. I like this way of prime factoring even more than what we do with the factor tree. Write this down in your notebooks. Write down using upside down division. There. Using upside down division. Okay, and I also had the other class write down these first 6 prime numbers: 2, 3, 5, 7, 11, 13. You're going to be using these numbers in particular quite a bit, so write these down. These are the first 6 prime numbers. There might be other prime numbers that we're going to use, but these numbers come up quite a bit. Okay. Now I'm going to get you a number here. Okay, the number is a fairly large number. We have 252, and we want to prime factor that. Okay. Now the mere fact. Now this is where we use those divisibility rules that I just gave you. The little blue things. Because this number ends in a 2, we know that this number is divisible by what? It's divisible by 2. So here's where we're going to start. We're going to put an upside down division bracket underneath that number. Go ahead and do that in your in your journals. Okay, and then we're going to put a 2 right next to that. So it's just like a division problem, um, but the bracket is upside down. Okay, now what's your question? Exactly, exactly. Yeah. So now we want to ask ourselves, all right, how many times will 2 go into 252? I'll spare you the suspense. Okay, it will go in 126 times. Now, is 126 a composite number, do you think, or a prime number? It's prime. I mean, it's not prime. It's a composite number. We're not done yet. It is definitely a composite number because, for one thing, it's an even number, and I know that 2 is the only even composite number. So we need to factor this out a little bit more. Put another upside down division bracket underneath that. Now it ends in 6. Oh, somebody said 3 too, right? Could 3 go into this? And how do we know that? How do we know that? Yeah, yeah, yeah. But let's talk about that rule of 3 with divisibility rules. If I added all of these digits up, I would get 9, right? Can 3 go into 9? Yes, it can. So let's put 3 here. 3 would go into 12 4 times and would go into 6 twice. Now I have 42. Is 42 prime or composite? Oh, it's composite. Think about my question before you answer. It's composite. It's far away from prime. So now this one ends in a 2, but if I add these up, what do I get? I would get 6. Could 3 go into this? 3 would go into 4 once and into, we'd have 12, 14 times? Is that right? No, that's not right. Yeah, that is right. Never mind. That is right. I don't have to use 2. I could if you want to use 2 instead. All right. If the 3 makes you feel uncomfortable, then we can use 2, and that's fine. 2 goes into 42 how many times? 21 times. Now is 21 prime or composite? It's still composite. What could go into 21? What? Let's try 3. 3 goes into 21 how many times? 7. And guess what? Or 7. I could have chosen 7 as well. Either way, it's the same thing. Now is 7 prime or composite? I'm finally left with nothing but what? Prime numbers. So if I want to know what the prime factorization of 252 is, well, it's 2 times 2 times 3 times 3 times what? Times 7. There it is right there. Or I could write this out as 2 to the what? Times 3 to the times 7 to the first power. Okay? Yeah.
What if you were like doing long division with the showing your work?
We're gonna be doing some work with some pretty big problems, but your divisors right here are always going to be prime numbers. That's an important fact. In fact, you may want to write that down over here somewhere on the side. That these always need to be prime numbers. Whatever you're dividing, your divisor, you want that to be a prime number. Let's do the same thing now with 495. 495. Okay, this is a composite number. We're going to use upside down division. Divisibility rules. What number could go into 495? What prime number? Maybe which one of these that I had you write down? Which one of these could go into 495? Allie? Why did you say 5? Because what? Because it ends in a 5. 495 ends in a 5, so I know 5 can go into it some amount of times. You want to know what it is? 45 times. Okay. Now, is 45 prime or composite? It's composite. So what do? I start over again, right? What number will go into 45? 5. 5 will go into 45 how many times? 9 times. Is 9 prime or composite? It's composite. Remember, here's our list right here of prime numbers 2 through 13, and 9 is not on there. So what prime number will go into 9 evenly? 3 will go into 9 3 times, and now I have nothing left but what? Prime numbers. That's right. So 495 prime factored would equal 3 times 3 times 5 times 5, or, yeah, 3 to the second power times 5 to the second power. Okay? So what I need you guys to do is make sure you have written these down. I want these examples written down in your notebook so you can use them for reference if you need them sometime. That's the whole point of the notebook, is your reference tool. Yes? Well, but here's the... No, it wouldn't. Okay. So we'll do some more practice with this using our whiteboard. So we're going to practice upside down division in prime factoring 80. Can someone walk me through this that thinks they might know how to do that? Who would like to maybe come up and do this? Candace? Yes? Come on up, Candace. All right. Candace is going to help us out here. Keep it like right about here, actually. Volunteer. That's right. Go ahead.
I'm scared now.
All right. Candace is going to walk us through this. So
Wait,
go
do
for
I
it.
explain it?
Yes.
Oh.
Yeah, verbally explain it all the way through. Just explain your thinking. Yeah, you can.
Okay, so first you need to put the upside down division thing.
Okay. That's correct.
And it can go into well, 2 times.
Right.
And it goes into 80, 40.
Uh-huh.
And it's still composite because the ending
That's right.
and into
Uh-huh.
and it's still composite. So we do it again. And 20 divided by 2 is 10. And it's still composite. And and 5 and 5 is correct.
Okay. Good. Good job. Now you might have done it a different way than Candace. So Candace, what is our prime factorization? Let's finish this before I go on here.
Prime factorization is 2 times 2 times 2 times 2 times 5 or 2 to the 4th power.
Yeah. All right. Give her a hand. That was well put. Well put, well taught, even though it was maybe a little quiet, but that looks really good. Now, you didn't have to start with 2. Some of you could have started with 5 up here. That would have been fine as well. No matter how you start, you're still going to get the same answer. All right, good job.